developing interest in interactive and generative art, as well as procedural and real-time computer graphics. In his practice, he operates through the fields of emerging technologies and experiential design, using the intersection of design, art, and technology as a platform for creative, immersing narratives. The title of his talk is Deliberately Unsupervised Playground, and he'll join you on the stage in a second. Thank you.
And also, I hope that you are now well eaten and ready and relaxed to participate in my talk, and thank you for taking time to sit through my presentation. I'm sorry if I'm misleading with the title that I'll be talking about unsupervised learning in video games, but I would really like to touch upon certain topics. First of all, because I'm coming both from the industry of not just say gaming, I'm really involved in real-time graphics, and I really use game engines in order to create one-of-a-kind experiences. I also come from academia, so I just want to take a moment of your time to introduce myself, because I'm not coming from any specific company today. So I chose to label, although it's unpopular, myself as a creative technologist. I come from the visual arts background. I'm a graphic designer that turned to new media, and then also got to abuse engines for the past 10 years in order to create those special experiences. Also, I would like to say that I'm specialized in new media and rapid prototyping, because I'm early adopter of game engines and technologies as a creative output tools in order to create those, let's say, never seen before, maybe sound pretentious, audiovisual experiences. Also, I'm a PhD student at the same university that I teach on, and my topic is I'm on a elementary school level. This is year 8 of my PhD studies about machine learning and generative art. So this topic, I enjoyed many of your talks today about that were both artistic and technical. And for me, it is very important to say that the departments that I teach on are based for new media, interactive media, so creating realistic and meaningful interactions between digital and real world, and also video game development. And I'm really passionate about that intersection of art and technology, because I strongly believe that they go hand by hand, because all the developments were made by artists, or in the past, Renaissance artists that were also engineers. But most importantly, when creating those interactions, I like to observe world around me, because in order to mimic it in digital experiences, you will hear me a lot to talk about experience design or experiential design, rather than video game design, digital design, and so on, because I'm in the field of experiential design. So for me, the most important thing is actually, this is my main slide, so please come back. How? So yeah. So as I said, I'm also roommate with 5 pets. So for me, they're all characters in my everyday life. So they all experience different behaviors. Like they are part of the same class. They are class pets, but they belong to different families. And they, okay, maybe the hamster and the squirrels are also the same family. But in order to create those meaningful interactions, if I observe them as NPCs, they are full of characters and specific behaviors, although they are all considered as my pets and something that is, let's say, they're to brighten up my day after a crunch that we all experience in the industry. So the topics that I would like you to touch upon today are for AI and games, for digital experiences and machine learning, and also the topic that is really getting all the heat now, it is AI tools for content generation. So first, let's start with AI and games, or let's say digital experiences, which is the term that I use intensively during this part of the presentation. So in its core, game AI is about perception. As I said, I showed you 5 of my pets to show that they can all be NPC characters, and that they all explore, we need to explore their certain perceptions. So when we think about agent or autonomous agent in the AI, we want to make it believable. And it is not the same how to make a believable opponent in a, let's say, a war game, a shooter game, believable opponent in a racing game, believable opponent in the real-time strategy game. So they all have specific behaviors that we need to mimic. So for us, it is not about only result, because with data science, it is about the results that we can use. And with game, which is apparently and most surely an artistic expression. We are about perception, how believable we can make that non-sentient synthetic life form that exists in some sort of, let's say, digital environment. So, come on. The receiver, okay. So this is important. It is in the context of the game world, because does my agent needs to know anything if it's human, how to be human, if it has only one role or several roles. So when talking about artificial intelligence and when talking about realistic behavior of the NPCs, it is really that there was several mentions of that topic that it's really dependable on the environment that we're using in creating NPC. But in order to make something more believable, we really need to start from micro interactions. So really knowing the environment around our NPC can really determine how we can create it, program it, learn it, etc. I will just also take a short break here, because in the core of what I do, apart from academia, is trying to augment the digital world with physical, not the other way around. I tend to use technology to use game engines to control industrial robots, to create autonomous vehicles and so on. I contributed on projects like that. So it is definitely not just theoretically, even it's practically possible to use not just game engines, but game logic in order to create really capable agents in a given role. So that's about what I would like to emphasize, in a given role. So practical use of artificial intelligence in gaming is for the most time based on, let's say, two approaches. If we are doing a simple patrol, so something we are using pathfinding, or we are using infinite state machines or finite state machines in order to control and create more believable non-player characters. When we are speaking about non-player characters, they can be familiars, pets, AI assistants, companions, or opponents. Because when we are speaking about autonomous agents, maybe the first impulse is to think about how can we beat the opponent. But in the context of the game world, even the opponent, the agent, is not the enemy. The game is the enemy. The agent is just one of the assets that is used for us to make harder for us to beat the game. It's just a means against us as a player. So all of our intentions in order to play is just they are determined by winning. I will get to that by later. So as I said, we can use either pathfinding or we can use state machines, but at least for the first approach that is, let's say, generally used. So also in the world of real-time graphics, we are constantly in the pursuit of game optimization. So many of the, let's say, commonly used techniques in the AI are not fully ready to be implemented in the real-time process, because I'm speaking about real-time graphics. Our graphics wants the piece of our GPU, our agents wants the piece of our GPU, everybody wants a piece of our GPU, and still technologically we are, let's say, almost there, and theoretically we are there because we found a common ground and common technology how to achieve the certain result. Now it's just a matter of how we use all these resources that we have in order to create, let's say, optimized or sequential use of those resources. So as I said, we believe it will change, and it is changing, because there are many great examples and experiments in the field of real-time graphics development that include machine learning and, let's say, real AI, opposed to what we learn with state machines and pathfinding. For starters, it's not just about receiver, maybe battery too. So although we are here to talk about autonomous agents as well, game engines are really using machine learning to optimize rendering pipelines. So this is a topic that is really really important for me, like from the technical artist point, that I can use now algorithms for image analysis in order to get better performance of the experience that they're creating. And recently, with all major and commercial game engines that are adapted, we have several very good integrations. Like we have, I know if you are like familiar, there is a great news in the world of game development. Unreal Engine 5.1 just released, and it has great improvements. And there is this great Onyx integration for it for some time, where there is this great like style transfer algorithm that is put there. So, you know, if you train a model, you can have a game world painted like Caravaggio, or something that is done in the way of the Chirico, or something. You can really use artificial intelligence in this way to leverage art style. Yeah, we can discuss that from the technical standpoint, it is just a post-process effect, but everything in the end is just the makeup, because we need to have a believable experience. So how we deliver our style? Firstly, the greatest improvement we can have is actually leveraging how our game looks. And if you have a capable art director, you can really have a meaningful and impactful experience. If anyone from the audience remembers the name of that game, feel free to interrupt me or just jump in. Hey, that's it. I came across a game that was completely created with mid-journey assets. Like someone was prompting for some time and creating assets, and then they were extracted from those images and used as a game art. And as a point, not only just as an experiment, but there is an interesting question about it. Who's the author of the game? You know, the game developer is the author of the game, but the assets are completely created by a deep neural network, but they are curated by human art directors. So this connection we have as players, creators, developers, and game developers, we're just using these tools in order to, let's say, attribute our ideas into finished products. So in this way, like AI is more present in gaming world than ever. Just maybe not in a particular way that we were speaking about, but techniques, even optimization like sorters like Mixamo, and also for auto rigging, are actually using those powerful models to analyze and to weight our geometry in order to get automatically rigged characters. So it's been for a while, at least for 6 or 7 years. But maybe under the hood, because if it works, no one, except maybe us in this room, are asking themselves, how does it work? It works, it's fine, let's use it in production. So let's just first go to, I believe that most of these concepts are familiar, that you're familiar with, but I will jump to them. So generally, when doing any kind of, let's say, patrol or simple agent, we have this navigation mesh. Navigation mesh in three-dimensional world is telling our agent where it can walk, where it can jump, can it swim, or is it walkable or unwalkable. And it's pretty easy to define it, like every major game engine, if you're not doing it from the in-house engine, has like a button, navigation mesh, and it becomes navigation mesh. But then we get an AI agent. I generally use this cylinder collider to represent it, because here we have just an agent. We don't know if it's a biped, it is an animal, is it a vehicle, is it a flying device? Because it really depends on the GDD, and once you're trying to prototype stuff and just to see if anything works, maybe it's not even important to which kind it belongs to. You just need a proof of concept. Does it work? Can it utilize it? So, like in its core, it is just finding the shortest route between 2 points. Nothing unknown about it. But if you have a starting point and any of the destination points that are randomly placed, and often are randomly placed in order to get our agents to walk around, it is okay. Like nothing wrong with it. But if you like put obstacles or put the environment, because not all of the environment can be considered as an obstacle, you get one of the like hello world problems with navigation meshes and navigation agents, that they tend to get stuck because their collision cylinder or collision mesh is too wide in order to go through navigation area. So you can do it quick and dirty and turn off the navigation mesh for a sec and then continue. Or now there are these new tendencies where you are actually generating this navigation mesh dynamically through the playground, because we have this dynamically generated worlds. And it is really exciting that the first and most important part of AI and utilization of machine learning and artificial intelligence is in generating these random vast worlds that we can use. And in line with that, we use it to create navigation meshes. So this was like when I started my first project in virtual reality was like 7 years ago, when we wanted to create this semi-photorealistic environment. Like just when the Oculus became available, we wanted to push it like 1080 cards just were released, and we wanted to see how we can utilize it. We used these 3D scans of people that were rigged, and we wanted to use them in order to create believable experiences. And just in order to make them walk, it was not, let's say, hard from the development standpoint to, you have a animation set, you have rigged characters, you have everything, but the not just performance bottlenecks, believability bottlenecks that we were facing were like once the inverse kinematics solvers just were put into place, at once you cannot have 10 or 15 agents, you can have 5 because everything is going on the CPU at that moment, and it is really fun, when they're walking on a plane, but plane is plane. There's nothing challenging about it. So if we give them like a ramp, okay, ramp, but it's not really believable to have an agent that goes up and down on a certain ramp. It needs a terrain, and also it needs to interact realistically with its environment. I will come to that in a bit. So as I'm saying, we have this like cone of perception. We really doing that project. We had to learn. This was all done by state machines and pre-recorded animations, so nothing AI about this. And we had these agents that are aware of their environment, but only at like very rudimentary level, that they know what is the obstacle, what is another agent, and if me as a player or participator of the digital experience can be or cannot be talked to or interactive. And we all know this part about games. We are often facing this infamous idle state. So we always have these agents that look approachable or not looking approachable. None of our agents, and it is just a technological obstacle, and technical, not creative obstacle so far, to have a believable character that looks approachable but doesn't look into you very inappropriately, so you know that you need to arrive in, because it is the only agent that is not occupied doing something like crouching or doing stuff. And actually, it is not only the part of narrative, it is part of the directing, because your interactive, realistic agent actually needs to be a co-star. If you are the main star of the experience, this one has to be a co-star, and it becomes like a hell to just direct it in order to look approachable at every moment. So this pathfinding, as I said, is often used only for using simple controls of our agents, so nothing. It is used with and alongside many of these other techniques that we are all aware of, and it is state machines. So we actually need to use state machines in order to get certain actions from our agents to perform and look believable. But state machines, we imagine them like the ones from the Westworld, and usually if you want to have the one that is functioning without a lag and has all sorts of scenarios for every possible situation, they actually they look better here. But if you were watching Westworld, you will know what I'm talking about. Or if you ever opened any state machine in a game engine, it often becomes crowded. So when it comes to state machines, we actually in production we use it as a mind. So let's say a mind, it needs to control both our perception, like what we see in the game world. It needs to control pathfinding, like where we can go and are we allowed to go, and also it has to have a behavior tree. Because in order, and I'm not speaking about technical stuff, like this is a collider, I can just, I cannot go through it, so I will go left. I need to have the idea that this is not the path that I'm supposed to go. So it comes not only with learning, but with a larger data set. So the behavior tree is the decision maker. And it is used like immensely in our industry. Like the more behaviors you have scripted, you can give the state machine to the game designer and let it direct what will and how it will interact. But in order to have believable animation changes, it is necessary for us to use motion matching for those believable animations, and also to do animation blending, and often taken from different animation segments. Like I don't know if did any of you in the audience ever use like skeletal mesh for a biped, for example, like in a game development? Yeah. So yeah. And you know that you can use like legs from one set of animations, hands from the other, and you end up masking in order to make it more believable. I will do this inappropriate acting one more time. So you do not have this, but you have like legs that are doing this, and the hands that are doing something else. Maybe you want to have someone take their phone, look out, or look left or right. It's all about randomness, because our behavior as individuals in the world, or let's say in the environment that we're occupying, is pretty much random. If I will look the recording of my presentation later, and I will try to count, or I will go through neural net, how much did I move? Not because I'm nervous, but because this is something that I'm doing on an unconscious level. And our NPCs cannot be unconscious. They can only do what they're directed to do through the state machines. And one of the key challenges when working on that sort of projects, when I had to define, we were calling them bots, but they aren't bots, those agents in our experiences, is like doing this characteristic, like we call them hero moves among the agents. Like we had a robot that is there to patrol, because the setting was in a distant future, and it is not a police robot, it's more than like a peacemaker robot that needs to make sure that no one is picking up trash on the wrong place and so on. And it has this sort of animation that when something is good, and when it comes to the group of people that are near some, it has like not high five, but it goes hologram, high five. You have this like social points, and it goes there. You need to give it context, because the movement without context really goes long way for the believability. Because you can have like the most advancedly trained, and I will get to that, agent, but if it doesn't behave naturally, it does behave as you expect, but not in a way I'm expecting it to sit or to go throughout the door or to talk with me. But it needs to have like some sort of emotional response. And it is how we are getting attached to the characters in the video games, how we get attached to the characters in the books or in comic books. And we have this like famous transition from the game world to the real world AI assistant, like we got Cortana from a game. It was invented as a construct. She was materialized like 15 years ago and we got it as an assistant because even Microsoft was like, we developed such a great concept of how AI looks, why shouldn't we piggyback on that and deliver it to the real world? So it is really interesting concept to see those kind of transitions, because also when most of us think about Cortana, we think about please be silent while I do my work, and I will turn you on afterwards when I finish if I need speech recognition for anything or help with the search. So just to get back on track with this, like the cool thing with this a large set of animations is that we can have this smooth animation changes. We cannot have this like laggy sitting on a chair or laggy pickup of the object and so on. That motion is believable or semi-believable, and also we have these accurate reactions. Like we can have someone that is excited or someone that runs over and so on. But there are also downsides, because as I said, we are constantly in this pursuit of optimization. We have this production scalability, because you have only a limited set of these motion captures or these animations. You rarely have, because of the time limits and the budget control over that animation one is delivered to you, and also you have this animation file size. And we are always trying to reduce number of keyframes, we are always trying to automate that stuff, but even if you end up with an animation file that is like 10 megabytes, it is still, much multiplied by 15 different animations that are not blended in a way, you get a really large file size. And also, I'm also speaking only about bipeds now. What about dragons, which have additional bones? What about characters that don't exist, that looks like Tulu or like a large octopus? You need to rig them. They also need to have their meshes animated. So that's where in the future we can, our projects will and are benefit from the concepts of digital experiences and machine learning. First of all, there are many interesting experiments, not just in the field of like style transfer that I was mentioning before. There are actually pretty cool use cases of reinforced learning when it comes to game engine. It is not really production ready. I've saw some experiments, but it's really cool that you can actually get a model of certain motion, train your model like to first mimic and then make decisions based on those models, and then apply it in your game. The only downside, apart from let's say a large file size, is that it's really slow. Like it takes time for you to only learn one agent to do stuff, and let's like translate it to 15 or 20 or 30 different characters that you need to encounter in your game or in your digital experience. So, but it kind of makes sense, because, as I said earlier in the presentation, our goal as players is driven by winning. And it really makes sense to train those agents also to win. Like not to be a means from a game for us to prevent us from playing it, but also trying them to beat the game. Also, I'm not here speaking about all those like Atari and also stuff that are now, that are now in the high from the experimenting. Like it is awesome that using only computer vision, you can train an agent to win in Pong. Like it is awesome. But there is no intention in beating me. It is just beating another pixel on the screen. And doing this, like learning from set of real players that were playing the game and transcribing those data into animations and decision trees, like it is highly conceptual but doable, you can actually make it as a more believable experience. So in a way, before I get to this concept, but this is just a graph, there is a really cool implementation, and that is why I actually mentioned Unreal, a new version of Unreal. There is this ML machine learning deformer. It's been there for a while, but I think that it is out from its development phase now. That is an actual plugin where you can use it with Autodesk Maya in order to load training data and apply it to a rigged model in order to learn from it. So there is a really like straightforward pipeline from one software to another in order to train your agents. The downside currently, but it is not a downside, it is inevitable in today's age, is file size, because it currently works as a Alembic file. I will not go into to be much technical about it, but there are, when you are modeling and animating in 3D software, you are using like native extension. But in order to export it for your game, you need to choose one of the interchange formats. And you have USD, you have Alembic, and you have FBX that's there for a while. And the thing is, I didn't try it because it's fairly new, but what I read about it, this plugin, and I'm really excited to try it, is using rigged FBX model, which has these bones, and then recording it to the mesh deforming geometry, and then imports it like to be animated geometry. You do not have bones, you do not have a rig, but you have a geometry that is deforming in a way of walk, and if you train it on a big enough set in order to learn how to walk, run, how to make a decision, it can be cool. But there is this thing like, are animators going to be needed after that? Absolutely, because we need to create those models, and when you are watching animated movie, you are never doubting about realism of that movement. Like it is completely centered about the world that the action is occurring, and also you need to have the same believable action in your environment that is game or some sort of digital experience. So you will always need not human to like make it believable, but you will need to make human to define what is believable in given state. That's why I started also with like in context of the game world. Like what is the most appropriate reaction to the certain environment that we are using. So if we like go just through this graph, this is not only for game development. I worked on a project like for semi-autonomous vehicles that also can utilize the same process. Like in this initialization, you know that English is not my main language. So we just need to define what is agent and what is the environment. So it is fairly clear. Then you need to get the current state of your agent, what it knows, and what it knows about its environment. When you get to that, you predict best actions from the list of actions that now knows how to perform. In first, I don't know, 10, 20 rounds, if you're learning your agent how to walk, it will fall. I believe that you all saw those awesome demos online when people are trying to make these procedural animations that are driven with reinforcement learning. So this is actually what is going like behind the scenes. So after all, you need to perform an action, and with all forms of reinforced learning, you are defining a reward. When the reward is given, update table and go and watch for the next reaction, and so on and so on. So as I said, because it takes some time, that is why it's not, let's not say production ready, but I don't know that any of us is on a deadline where he can wait for entire game to be trained this way. But I wouldn't say that it won't be possible like in 2 years. So because now we have even plugins that are here for the scientific purposes that can perform this action. So as I said, it takes some time, but even Rome wasn't built in a day because there was no pre-trained model for that. So once we are making models based upon which can train those networks, today was a lot of great talks about how we acquire data and how we use them. And for me, as a digital content creator, I'm also capable and am producing a lot of data that can be used in my niche industry in order to train these networks. Like it is awesome to track what are players doing, but it is also awesome to track what are creators doing. So in that way, you can actually make believable assumptions of your agents, what they can and won't do. So in this way, this is mostly about the title of my presentation. This is deliberately unsupervised, because we are really free to do whatever we want, because there is no defined pattern. Like the point in civilization that we are now, with this intersection of real-time graphics, never seen before computer power, and professionals from all fields that are merging into, let's say, data analysts and AI fields, we're all here, we can like intersect our experiences and create believable products. But because in the end, if we have a believable NPC, again, people in this room will ask themselves, hey, how did they accomplish this? This is awesome. But our players and will be satisfied. You know, because we created a believable experience. Like when you see a bad acting and a good acting, you see a good bot and a bad bot. So no, not in a way how good bot from Reddit, but really, really, really good bot, essentially. So it takes some time, but it will be okay. And if we go to the example, if this works. So ideally, if we talk about realistic NPC interaction, we can group it, but not limited to, let's say, 3 approaches. We needed to perform 3 functions. We needed to do some sort of exploration, so it needs to navigate through the environment. We need to be able to perform some sort of dialogue, even if it's generated by text or by, speech. And we need to do object or environment handling. In a way, I'm now speaking about digital world, but this is also really applicable in real world. Just add some computer vision into the mixture, like LiDAR technology or anything, and you can do this also obstacle detection and object detection, and even you can do like friend, enemy. When I said that I worked with those semi-autonomous vehicles, this is exactly the approach that we were using. So for exploration, we can use pathfinding. I started from that. For dialogue, we can use any sort of natural language processing, like text or speech-based, or even how to create a background music for a certain atmosphere. Like if I'm facing a really sad cutscene or really emotional, I can use it to, based on the dialogue that is generated, also generate background music which will amplify my experience. Because in a way, we are directing the whole experience of our player, not just the believability of a certain agent. And also for interacting with scene or environment, that sounds like a task for reinforced learning. Because yes, our agent only knows what is defined in the environment, but it doesn't mean that we cannot also dynamically change and update those rewards and those environments, not maybe real time now, but very soon. The way we tend to do those things is like to replicate the places that need to be augmented with real life controllable semi-automotive and semi-autonomous robots, that they are aware of their environment in scale 1-to-1, and then just change those stuff. It's not just, but it is something that is, I believe, clear to all of you here. So, and in the end, for this, yeah. So as a real-time content creators, we really need to like reinvent a strategy to earn a reward, because in order to just get a reward, you will go through like 100 cycles, and you will learn your agent how to walk or how to go out through the door. But what determines how to act in a certain situation is how to define those rewards. Like, if I stay in the room, I will be rewarded by this, and I will get some other opportunities. Maybe my experience level as an opponent will rise. If I exit the room, I will be deleted from the system memory. So in a way, this is really a creative problem, like for all of us that are in technology, like how to define these strategies in order for our agents to be not just more autonomous, they need to be more believable. And for this, I didn't even start about face capturing and facial expressions, because this is the thing that we are not liking the most, but we get looked upon over. Because in a way, if it looks believable and speech is during these scripted sentences, it looks okay. But think about real-time generative, mesh deformation based on NLP. Then we're talking about really believable stuff, and it is all possible in theory. And even in 2 or 3 years, maybe be possible to deform mesh real-time. There are these awesome projects, like this codex integration with Babylon.js, where you can actually enter those prompts and create a red sphere that is on top of the cube and so on. So maybe you can, in several years, actually just give a prompt like, I want a smiling face that is acting cheerfully, and we get this base mesh that is animated, and actually, as an artist, we can get and model around it or animate around it. So, and one plugin that I want to make point on is this MindMaker AI plugin. This is a plugin for Unreal Engine. Most of these plugins for reinforced learning are paid, but this one has actually a free demo that you can test out, and it has several examples that you can cover here, and which are really cool. I'm in no way related to this project. I just use it, and I'm very satisfied with how it works. But I believe that when you pay for it and you get the support for it, you can actually use it for a game. The thing is with this reinforced learned agents is there is a game, I think that it is called AI Rogue, but correct me if it's not like that, which is completely like generative, and it learns from the player. But it comes with specifications that if you don't have a certain configuration of your PC, there's no use of you for playing it, because I'm quoting, you will get a mediocre intelligence. So we are here, like, not even theoretically, but even practically, there are people that are developing games that are based on reinforced learning that we can deploy and make our experiences more believable. So, and like lastly, the thing that most of the people from, let's say, my industry are shaking off, like AI tools for content generation, many of those questions are raising is like, are they going to replace the artists or anyone in the process? Of course, the answer is no. And in a way, like coding and programming industry is going towards, yeah, I want to write human language and I want computer to execute my code. Artists are like, there's Midjourney or Stable Diffusion or DALL-E, I will be replaced. No, because in a way, there is still needed an artist or a visually literal person, in order to curate that stuff. So you need to actually select what is not trash or rubbish and deploy it as an art style. So being in this part of like civilizational uprise, where I can use like several prompts to get this really cinematic and cool looking stuff for free, like for me when doing art direction for anything, this is awesome. And I'm in no way offended to be called creative prompt designer, because in a way, all of my design process comes from prompting. I have an idea which I want to sketch. What we in academia use keywords, here practically we use it prompt. So I see no problem with this. And actually this can help me decide not only about art style, but because about the mood or anything. And even these are like DALL-E and Midjourney. And I have a next example with Stable Diffusion. Like this is my favorite example in this presentation, just if it changes. So yeah, this is like the most authentic stuff that I created. This is like Middle Ages Serbian village in the style of H.R. Giger. So like you get this like really authentic like linotype type of a graphic just by prompting, because you have a acquired taste for stuff. Like now, the possibilities, and it is not just a buzzword, are limitless in a way. Not just creating art styles, but when Midjourney first was released, and I joined their Discord server, I was using it for all the prompts to create imaginary animals. I was like, I want the head of this, the tail of this, and amount of legs, so I can use it later in my character development for games, or that's for concept art. So in this way, like we really need to, as a whole, like lift up this hype. Let's call it hype about this, because this is only a tool. You don't say that someone is less of an artist because it uses Photoshop or Maya. It is just a tool to achieve a certain goal. And for us, the goal is like consistent art style. And if you are working with a young team, which does not have the visual literacy, and also you can help them achieve consistent lifestyle like with 10 prompts. And tell them, follow these rules, follow these palettes, try what can you do with this. Same goes with this automatic, there are many of those auto riggers now, auto animations. You can actually upload video and you can get motion tracking out of it, like for free, for 30 seconds. So in a way, like if you have an inexperienced animator, you can use it to a video of yourself of a motion you want, extract the motion tracking data from that and tell, hey, let's try to mimic this. So really in a production line, we have reinforcement learning, like we are almost there, but all of these other tools are here for us to leverage our production time and to make these believable results. And so I really have, this is my question for you for the end, but one of the like most awesome stuff that I found out, yeah, thank you. So I don't know if you heard about podcast AI. This is like something that really blew me when I found about it. There is this like interview of Joe Rogan interviewing Steve Jobs. Like this is state-of-the-art speech genesis, and this is like awesome because now we have like voice actors mimicking historical personalities in order to make something more believable. And what if you can now use, okay, there are no recorders of Nikola Tesla, so you cannot like mimic him, but you can mimic any person from the 20th century that has a recording of their voice, and you can actually use voice actors to create new iconic characters. Because now we are just using them as assets to give some sort of believability to our agents or to mimic certain personalities from the role. And if you can have this advanced NLP algorithm that is actually, I really encourage you to listen to this if you didn't, because they're actually showing so much of emotion and character in that, like they're laughing, they're using, and so on. So it really looks like a podcast, and this really blew my mind. So this is a project that really needs to be kept an eye on in order to make this like interactions more believable. And in the end, I have this is a Q&A, but also a question like when it comes to the artificial intelligence and believable interactions in bots, would you believe to artificial intelligence merchant in the metaverse? Like it is, understated with trust. And in order to make something believable, we need to get this, it needs to resonate with us in order to gain trust. We do not trust any of our NPCs in the games. At least I'm not trusting any of them. Even if you can have a friendly fire. I don't know. So because I do not know their attention and am unavailable to obtain any information about their intention, which, equal signs for intelligence. Intention and intelligence go side by side. This is like the crucial question, like what if we need to get involved with something that is materialized, like money. Make it $1 or make it 300 dinars or so. Would you give it to the algorithm to trade for it, buy or acquire it? Or you would Google who is behind this, how can I get this on my email so I can get confirmation? So believable interactions will be believable once we gain trust from these autonomous agents. Not like doing Blade Runner tests, are you, are you bot or not? But in order if we make their reactions more believable for us to get to interactions with them. So this marks the end of my presentation. I would like to thank you for your time. And I don't know how much time do we have. Do we have any time for Q&A? No?
Yeah, let's do like 1 or 2 questions.
Okay. But I will be here, so we can continue.
Can we have at least 1 or 2?
If not, we can continue with a cup of coffee.
Still, we're running. Oh, okay, we have 1.
But yeah, after this
this Q&A session, we'll have a 15 minutes break before the...
How much time do you spend like training your agents, and what is the size of the world, the number of entities, and
So it really varies from project to project, but like the largest, because we were using the real world scale for that, we used it for 16 meters of depth and 8 meters of wide, and we spent almost 2 months training them to be aware of them, because we have several autonomous agents that were going at the same time, having their own mind. And the most of the time that we used to train it was actually to make them aware that they are not the obstacles. Like the world was scaled and mapped really quickly, like with LiDAR technology, like we know what is obstacle. But if they approach to other moving object, is it an obstacle or is it something that is other agent? Because you have people that are going around in that space. And also, so almost 2 months was for this basic training, and then the scaling and the cleanup. I won't lie to you, there was also some actual tweaking afterwards, like we needed to correct those behavior trees and limit some of the behaviors, but it is far from done. It functions in certain conditions, like in that room that was mapped, but it is scalable to any other environment that you scale it. But 2 months was for this because we use the LiDAR technology. I believe that it would be less in digital world, but for us it was many obstacles and challenges using reflections and everything. It was all mixing up with our sensors. So this part of the question I could only answer from the practical side in the real world, if it in any way touches up to something that you were asking for.
Okay, thank you.
Okay. You're welcome. So if we are running out of time, please find me so we can grab a drink or something, or find me at Ben Akiba tonight. Thank you.